I really want to make a transceiver, and I'll be doing lots of experiments towards this, including some of the videos you may have seen about using the ProgRock2 programmable crystal from QRP Labs. So anyway, I've come to the conclusion that I need a VFO, if for nothing more than to test everything, but also possibly to be part of my future completed homemade rig, something I've always wanted to do. So anyway, the ProgRock2 is based on the Si5351 chip, and these are also available with these little breakout boards, and they connect to Arduino or other processors through the I2C protocol. And Jason Mildrum, NT7S, made a library for the Arduino which enables you to control it. It's really good, and lots of people have written Arduino sketches, the software for Arduino, and have made it available, and other people can rewrite it and adjust it to suit themselves. And I've downloaded mine from M0NTV Nick, who's very kindly shared his work, and he acknowledges the work he's built on from other people, and so do I. Thank you, everybody. And if I share my version of this, I will make sure those acknowledgements are noted at the beginning of the script. So anyway, here's the breakout board, and I've made one version of this. I'll just turn it on in the hope we might be able to see it. And this is with an Arduino Nano, and I put it in a jelly bean tin which screens it really effectively, and when I turn the knob you can see the frequency change, I hope, maybe in a big way if I do this. And it works really well, but they all need calibrating. So I have another version here I've made on a piece of solderable breadboard, and that just has an Atmega chip on it, which is the same as in the Arduino Uno, and you can program it and you can make the actual physical circuit to be however you like. So you can attach things to it, which is what I've done. And I hope in another video I'll share details of how I did that, and also about the software. But today's video is just about the calibration. And again, I've been seeing what other people do, and I've found it really difficult to use an oscilloscope or a spectrum analyzer. I have the tiny spectrum analyzer, so I don't have an expensive one you can use, but I haven't found any of it to be able to get me to the accuracy I want. So I've decided to try this by tuning it in as if it were a radio signal, and I'm going to listen to it on my FT817, and to get the accuracy I need built into the software, I'm going to use Jason's downloadable Si5351 calibration sketch for the Arduino. So in a moment I'll have all this set up, I'll show you how I did it, and I'll see if I can get this to within a few hertz of the frequency I want and keep it there. I'm now ready to calibrate the Si5351 VFO using my FT817 transceiver. I've had it switched on for quite a while. It's in receive mode, obviously. Turn it up a bit, we'll hear static. And as an antenna, I'm using my dummy load, which is just in a 3D printed plastic case. So there's no metal screening, and I know it will pick up the signal because I've tried it before. So when I load the software, the VFO will default to 14060, which is how I've set it up, which is my usual frequency for starting my QRP CW sessions, and I've tuned the radio to that frequency. And when I want to hear a station or reply to a station, I zero into it by holding the home key, listening to the offset tone, which is 600 Hertz, I believe, and then adjusting the other station till it matches it. And I'm going to do the same with the VFO, maybe not on 14060, we'll see that in a minute, but hopefully this will be exactly the same kind of thing, and I'm confident I can get that to within 1 or 2 Hertz. So let's go ahead now and load the software. And let's take a few seconds, so I'll skip over it in the video so you don't have to wait. And in a moment there'll be the splash screen and then the tone. There's it loading. And now we're picking up the tone, which I hope is clear to hear. And if I press the home button, now we can hear both tones and hear that they're quite different. And can I tune them? So now they sound roughly the same. but we're saying 14060.31. So obviously I need to adjust this. So the next thing I'll do is load the calibration software, which is supplied with the Si5351 library by Jason, which is very kind of him, and I'll use that to find a correction factor to bring the two frequencies to be the same. So I'll just get that ready to load and we'll carry on. I've loaded the calibration software onto the computer, and in a moment I'll load it onto the Arduino circuit, which will prompt the Si5351 to switch to 10 megahertz and output that. At the moment, I think my Si5351 is still outputting 14060. There it is, yeah. So if I switch to 10 megahertz, that's now disappeared. And when I load the sketch, this screen will stay as it is because the LCD's not being used in this calibration sketch, and after a while we should hear the 10 megahertz tone. So let's go ahead now and load the software. And I've lost my mouse. There it is. Here we go. So with the calibration software loaded onto the Si5351, I can now hear 10 megahertz signal coming through to my FT817, and we can hear that they're quite different. The offset tone is considerably lower. Now if I open the serial monitor, I can send commands to the Si5351 through the Arduino and change the frequency using these letter codes up or down. And I'm going to start by sending a K, which will drop it by 100 Hertz. Here we go. Let's compare that. It's about halfway down. In fact, I'm going to try and send another K, another 100 Hertz down. Enter to bring it down, and that's extremely close already. You can hear the note beating. It's just 1 or 2, or maybe a few Hertz at most, probably 1 or 2. So that is actually really straightforward, and I'm just going to leave it there. And if I press Q, like it says on the screen, and enter, it tells me my calibration factor is 20,000. So now what I need to do is to go back to the Arduino VFO software, here it is, and enter that number 20,000 in the correction space, correction factor, and I'm hoping in another video I'll explain a bit more once I've sorted out the version of the software I'm using, which is obviously adapted from other people's software, how this is done in a bit more detail. But for the moment all we need to know is we need to put that number there and then load that. I'm going to do that right now. Here it goes onto the Arduino, and then this tone should disappear in a moment because it will default back to 14060 as a VFO. Right, so that's now loaded and the tone should change in a moment, so let's switch the radio back. And there it is on 14060, and shall we listen? And they are virtually the same, with just a slight beat note in between. So if I now change the VFO to a different frequency, let's move it 100 kilohertz to 14160, and if I, as quick as I can, adjust the radio, it should be the same. Let's see, nearly there. 1454, there we are, 14160, and does it match? Yeah. So it's retaining the frequency, it's very close. There will be some drift, it won't be perfect, but I've got it within 1 or 2 Hertz, and I think that's absolutely fine if I use it either as a receiver VFO or as a transmitter VFO. It's going to be pretty accurate and certainly good enough for the CW QRP that I use. So now I can disconnect the computer from the VFO and just use it, and if I want to make any changes in the future as to how it works, I can go back into the software and set it up again. Of course, I'll be coming back to this again and trying to get it a bit more accurate. It's nearly there, but it could be a little bit better. And obviously I'm going to have to work on the software and hardware and do all sorts of things before I turn this into a working radio, which I hope to do before too long. And I hope obviously to make more videos about it. So thanks to everyone who's contributed to all this, and there's so much information available out there, and I'm just making sense of it myself and making my own project based on the encouragement from others. So thank you to all of them, and I hope you found this video interesting and maybe useful, and I'll be back soon with more videos about electronics, radio and so on. Thanks for watching.